All right, welcome back everyone. This is Devarshi here. In the last video, we saw how Python actually resolves the imports, and we saw a very simple way to bring a Python project written by your friend or someone else into your main program using the sys.path.extend. And I told you that it's a sort of a magic, not a standard way, it's kind of jugaad. And in this video, we'll see for a much more standard way to do that. And the rest of the topics are listed here. Pause the video for a minute and take a look at all of this. And at the end of this video, I promise you will be able to distribute your project and you'll be able to set up any Python project locally using the package manager. We'll also see two kinds of package managers here. One is pip and other one is uv. It's a most modern package manager for Python, just like npm for Node.js. We'll see all of this. Take a look at this before we proceed. Okay, let me start with the first one, package library distribution. Okay. Let's start with the basics again. A quick revision to package and modules. See, what is a module? Any Python file that you write can be called as a module. Just a fancy name given by Python. Even the other languages calls any file that you write, any code file that you write, as a module. Now, what is a package? Package is a directory containing these Python modules. A package can contain nested packages, as you see here. So we have a source directory in which we have two packages, Samsung Math, Calculus. Samsung Math has two modules inside it. Calculus has again has two nested packages inside it, which they contain Python modules. And the other one, Calculus itself, has two Python modules, differentiation and integration. Just an example, quick revision to modules and packages. Now, what is a library then? You might have heard the word library, like pandas library, numpy library. Whenever you are importing, import pandas, import numpy, import matplotlib, you might have seen someone, or you might have unconsciously or without understanding the real meaning, you might have said, "Hey, I'm importing numpy library here," and some people would say, "Hey, I'm importing numpy package here." So what's actually the difference between package and a library? See, library is a very generic term. What I mean by this? See, library is a collection of code that you bring into your main program. Let me rephrase it this way. It's a collection of code written by someone else or maybe written by you. But this collection of code is not a part of your main program. You're bringing it from somewhere, from some other directory package or anything, into your main program. And could be this is not a part of this. It's not actually you don't develop this by yourself. Someone has developed this for you and you are bringing it into your main program. And this collection of code can contain, it can contain modules, it can contain packages, and inside them you can have classes, functions, variables, so many things. So it's a very generic term, collection of code written by someone else or maybe you, that is not natively a part of your main program, you bring into your main program through the inputs. Then what is distribution? Okay, package from the perspective of Python package installer. Like might have written pip install numpy or maybe matplotlib, jax, anything. From the this is from the perspective of pip. It might confuse you a little bit now, but stick with me. But at the end of the video, you will be able to clearly differentiate between packages, library, and distributions. Hold there. Hold over with me. So distribution. Do not confuse this with a statistical distribution. Distribution in this context means something that can be distributed. Mhm. Something that can be distributed. Now, what do you mean by distribution? Um, this distribution is like same thing. Actually, this is also a collection of code in the Python distribution. This is also a collection of code, but it contains more than this collection of code. Uh, it contains a version of the project, contains also the author's information, the build information, how to build this project. We'll see what is building in the next few minutes. And it also contains the dependencies information, like or like what are all the other Python packages or the libraries this collection of code depends on. Or maybe this collection of code can be a Python project. Let's say this is a Python project. This depends on some other Python packages like maybe Jax or Matplotlib or NumPy, anything. It contains all those dependencies information along with the versions. Also, it contains also the version of the project. And this distribution, if I talk literally, it's actually a zip file. This distribution is a zip file, or in another way, it's a Python package neatly packed in a format which can be distributed. So distributed means you can give it to others. It can be distributed via Python package index. That is what distribution is. We'll revisit the definition again. Okay. Next one. So with this in mind, we saw module package, the difference between library and a package. Sorry, the difference between library and a distribution. Let's understand the need for a virtual environment. Okay. See, let us say whenever you write pip install some package name or maybe library name or a distribution name, anything. Let's say whenever, do not get confused here, whenever I use library, package or distribution, I essentially mean the same thing. Something is there on the cloud and I'm bringing it. So let's say I'm calling it a package. So I'm using all the words interchangeably. Don't get confused with that. Package. Pip install package name. What actually happens? So it installs a package into your computer on some location. So that location is basically probably this location. Depending on your Python version, it may change. But if you are using the global Python, so without using any virtual environment, I'm just using pip install. Say I'm using pip install NumPy. It installs the NumPy package, and you see requirement already satisfied. That means I have already installed it. NumPy in this location. C users 2D roaming Python side packages, and the version number is 2.5.1. Okay, no. So at this location, you have that package installed. So what's happening? Okay, that's true. Yeah, both are same. Let me delete this one. So whenever you install a package, that package gets that package along with the version number, let's say v1.0.1, v1.0.2. That package gets installed in your side packages. And whenever your project needs that, let us say there are two projects, Project Alpha and Project Beta here. And all these packages, by the way, when you install pip install package name, your package manager goes and looks at this Python package index. So this is a it's like a hosting platform. It's a platform that hosts your software repositories. So the others can, like you can distribute your package there, and the other users can pull that package using the pip install and use it in their own projects. So this is a platform for hosting your software repositories or distributing your package repositories. When I say distribution, you are giving it away to someone else. So like you're making it available for other users so that they can use your project functionalities, classes, functions, or anything that you have developed in your project. They can use that in their project by installing it via uh, package manager from Python package index. Okay, that gets installed here. Now let us say we have two projects, and these are the dependencies of these two projects. Project Alpha depends on package A, package B, package C, along with their version numbers. You see package A of version 1.1.5, package B 0.0.2, 0.1. And do you see this one? Both of the packages have a common dependency, that is package B, but the versions numbers are different. So it is 0.0.2, it is 2.1.0. Okay, when you are running this project, so basically what you will do, you will install all these packages using pip install, and yeah, your package manager will install these in this one. Let me do it this way. Oh, yeah. Your package manager will install these packages in your side packages, this this folder, and whenever you write import package B, import package A, that gets pulled from this directory. And we saw that in the last video. No. Okay, this is fine. Project A will be running, everything is fine. Now when you come to project beta, project alpha is running fine. Now when you come to project beta, so your package manager, when you pip install all these packages, so your package manager sees that, okay, there is a package T. Fine, let me install it. Package T gets installed here. Okay, there is another package E that gets installed. Package E install. Now what about the package B? So it says that your current project needs 2.1.10, but it found another package here 0.0.2, and this is a conflict because the version numbers are different. So what will it do? It will erase the package B, deletes it from here, and installs the new version of the package, for the package B with this version number. Okay, so and now the project beta works fine. By the way, package E and package B doesn't affect the project beta because it is not importing anything there. So Python package manager won't touch them while you are inside the project beta. Everything is fine. Now, do you see the problem here? When you go back to project alpha, what the package manager sees, hey, there is a version mismatch for the package. Let me slide it a little bit and turn off my hand. Okay. Hey, it'll see this one. Package B depends on we need a package B with the version 0.0.2, but what we have here 2.1.0. So then when you run this project, it will break. So you have to, this project will definitely break. So you have to change the version here. What will do, it will erase the package B again, erase it, bring the new version. So from the Python package index, from here it will bring a new version. Fine. Now the project alpha runs fine. Now Now when you go back to project beta, what do you see? The version number mismatches again and it will break. Now again you have to install a again you have this will go and erase this project package B and it installs a new version. Okay, I guess now you understood the problem. I need not to articulate the problem even more. I guess you understand the problem. What's the problem? This is called version conflicts. Like one package depends on a like one project depends on a certain package of certain version, and the other project needs the same package but with a different version, and these end up in a version conflict. By the way, you might ask me, hey Devashi, why can't we install a different version like Python? You can do this, right? To install the package B, two versions of package B. Package B, you have another version. Then this project can use this version, this project can use this version. You might say that. And actually a great idea, but Python doesn't work that way. You can only maintain in the like this is a global site packages. You can maintain only one version of the project at a time, and you cannot do that because you understand the problem, right? If you are importing NumPy in, let's say here, if you are importing NumPy, you just say the package name or the library name, but you don't say, hey, NumPy is equals to 1.0.1 1.0.1, I want this version number. Do you say this? Even the Python syntax won't allow this, and this doesn't work. So you can only maintain one version of the package inside this side packages, and this ends up, these two projects ends up conflicting with each other. And when, especially when the dependencies increase, this will create a chaos in your project. And you also see the another problem. You cannot, so okay, let's say you're okay with this. You're not worried about this version conflicts when you're switching between the project, and you're okay to install the reinstall the packages every time you switch the project. But you see, do you see another problem? You cannot run project alpha and project beta at the same time. You cannot run them because they completely different on the two different, they completely dependent on the two different versions of the package. That's a problem. So to solve this problem, we resort to virtual environments. Now, what is a virtual environment? See, virtual environment is like this one. It's a, you have a project, say maybe you have a project, let's say this is your project gamma. You have this project, okay? You will have some sort of some dependencies for this project, okay? Virtual environment is like for this project you create a separate environment. In this separate environment you will have a separate Python interpreter, we'll have a separate Python interpreter. One more problem we missed to mention in the previous one. What if this project depends on Python 3.10.1 and this project depends on 3.13.2. Just don't get confused with these version numbers, okay? Just a random one. What if these two projects depend on a completely different Python interpreter versions? How would you do this? Will you uh, upgrade and degrade the Python interpreter all the time? This is another big problem. So, and when I say this, so Python 3.13 cannot support this project alpha, and it doesn't work there. Okay. Now in this case, you need completely different versions of Python interpreter altogether. So there's a problem, and we solve this problem using virtual environment. In a virtual environment, okay, what is a virtual environment? Let's continue with this virtual environment. It is a separate space or a separate sandbox for your project where you where you will have a separate Python interpreter. Separate Python interpreter in the sense it can be different. It can be different from the global from the global okay global interpreter version. So when I say global interpreter, it's this interpreter, you which Python, it's this interpreter. Oh, yeah, I'm in a virtual environment here. 1 minute. Okay, which Python? So it's this Python. In the C drive, you have Python 3.14. This Python interpreter I'm talking about. This is global one. So depending on the drive, you might have depending on the records of Python installation. If you have configured a different folder for it, you will see the Python there. So this is when I install the Python from python.org, I installed at this location, and this is my global Python interpreter. Now it can be different from it. So if I can create a virtual environment for this one, I can install 3.1 separately for that and 3.13 separately for this. And this virtual environment doesn't affect the other projects packages, because the packages installed here are completely isolated from the other project packages. Second one, yes, you have a so how does it affect? It doesn't affect, because when you create a virtual environment, this will have separate site packages folder inside the for this package for only this project. Okay, then that's it. This is a virtual environment. Now when you create a virtual environment for this, so let us say I want to create a virtual environment for project alpha. Let me take this one, say project alpha is here. So this one, I create a virtual environment for this one, say this one. So what I do, I install Python 3.10.1, is that right? Yes, and all the packages here. So in this one, you'll have a separate site packages section. There I'll install all these things. Now, so isolated. This is an isolated one. Now for the project project beta, we can have separate Python interpreters 3.13.2, and this can have its own packages. Let me delete this one. Okay. Now there is no problem. Whenever Python interpreter want to in this project, while you're working in the project beta. Let's say you are importing a package B, so that gets imported from this own side packages. That will not see this project packages because they are completely isolated. This is project alpha's virtual environment. You have a different Python interpreter, different side packages, and this project beta has a different Python interpreter and different packages installed location. And that's it. So this is the solution for the uh, this is the actually solution for it. This is why you need virtual environments. Okay. Let's see. Okay, we'll see how do we create a virtual environment and next eventually probably after a few minutes. But before that, we need to install understand how do you distribute a package. Sorry, how do you distribute your project? Fine. Okay. Yeah. Now let's understand the problem with the previous method we used to bring a Python project written by someone else into our main program. So using what actually the problem with sys.path extend method for importing other Python projects? Come back. So we used this last time. Now, what are the problems here? I can mainly identify three problems with this method. First one, so whenever the person who wrote the original code, whenever he updates the project, like he makes some changes to the classes functions inside the project and he makes that change. How does he propagate that change to you? He again have a, so I hope you remember how did we do that last time. So we that person will zip the file, send it to you, you'll extract it, add the folders path to the sys.path extend, then you can use it inside your project. So managing the updates becomes very difficult. So because every time he cannot send you a zip file, and yeah, it's difficult. Second one, versions. So versioning of the project is difficult. Again, you cannot. It's really difficult to tag the version names with those kind of folders every time they sending you. Other one, dependencies. Let us say that project depends on 10 other dependencies. You need, and maybe that person has to tell you, hey, these are the projects. These are the packages my project depends on. So these are the dependencies. Maybe the first one is a rich library to NumPy, maybe the pandas, and blah blah blah. So many things could be there, and he will send you a requirements.txt file. Maybe you have to manually install them, install those packages inside your project. Second one, the third one, distributing it to a large number of users can be hard. So distributing, I hope you understand it here. Distributing means making it accessible to large number of users. So it is really difficult to make it accessible to large number of users. If you just put it on the, if you put your zip file on the cloud, maybe a Google Drive, and share that share that drive link to everyone, fine. How do you manage the updates and versions? It's really difficult. How maybe you want to yank a particular release. How would you do that? Yanking means just warning them not to install the particular version. And yes, dependencies also management also becomes a problem. Now at this point you might say, like if you are just curious or something, at this point you might say, hey, if pushing updates to the users is that difficult, or distributing to a large number of users, you're saying it's hard, I can use Git with it. I can use GitHub for managing updates and distributing it to large number of users. I will expose my project in the some GitHub log through a GitHub repository, and the others can uh, use it by using git clone or something. I would say if you have thought about this, I would say great move and congratulations, you actually thought about solving the problem. But GitHub is built for a different purpose altogether. It's not for this package management or this distribution purposes. It is purely built for development purposes. You may be able to push your updates to a GitHub and the users can pull it. Okay, fine. But the problems are still there. First one, dependencies. You still need to manually install all the dependencies. Let's say you added a new dependency to your project. The user have to manually install that from somehow he has to manually install. Third one, you are pushing the whole project to the GitHub. Don't you see? Then let's come back to our demo project. You see that, let me delete this virtual environment. We'll see how to create a virtual environment in next few minutes. Let's say this is our project, okay? You have some documentation here, source code. Inside that source code, you have all the packages. The other one, you have tests, some maybe main file. Let's say this is main file. No, and you know that the main source code lies here. If I'm giving this project to someone else, this is the code they have to use. This is the source folder, and whatever code I write, the main code of the project lies in the source code folder. Why should I give them docs? Why should I give them tests? Why should I give them so that you could have 100 different folders which are not meant to be distributed, like which are not meant to be given to the user? How do you manage that? But if you put them in the git ignore, then that's a big damage to the project, because GitHub is for development purposes, and the other developers working in your team have to know that they have to access these logs, they have to get access to this and all of that. So GitHub is built for development purposes. This is not meant for distributing your packages, Python packages. So Python community back in 1990s, they actually thought about this problem. They became serious about this problem and thought, hey, this is something that we need to take seriously. So they said, okay, if distributing packages is that hard, let's make it easier. So they said, what did they do? So they said, hey, you have to follow a standard. Okay. Okay, fine. You have to follow a standard. So every time you build a Python project, you must have a file called Pyproject.toml. So this contains all the information, about the project. Like what kind of information could be let's say version number, project name, and project name in the sense this is the package name. Let me close this. Okay, project name. So project name is like you see numpy pandas while importing that is the project name. So they have actually that project. If you are installing, numpy pandas through import numpy, import pandas, like pip install numpy. So that is actually the project name. So whenever a package So a package manager will identify the library or the package you are distributing by your project name. Third, it contains the dependencies information. Dependencies. Missed it. Contains the dependencies information. Maybe also the author's information. 3. The build information. So build info. How to build this project. Hey, building is nothing but I'll give you a very simple definition for building. So what is building? Do not confuse this with the building binaries of C++ or Java project. So this is quite different in Python. So building is like packing your what's this? Packing the code of your project in a neat format, in a neat file format. The code is actually a zip file or tar zip file, which can be distributed via the package manager and Python package index. Let's delete this. Okay, this is a simple definition. So what's the process? Building is the process of packing the code of your project, neatly packing that code of your project into a file format which can be distributed. How that distribution happens? You will distribute, maybe you will so this file, the output file, is called a distribution file or a build file. We'll also call it as a build file. So this file can be shared to the user and they can install it with the package manager. You can share it to the Python package index, the cloud platform where all the packages are software projects are posted. From there, the user can install with pip install. Okay, this is building. Now they said, okay, you have to write a Pyproject.toml in your project, which contains all this information. Okay, let's see. Okay, let's take this time to see what actually a Pyproject.toml contains. So I have a Pyproject.toml here, very basic version of it. So it follows a language. See, this is not JSON or anything. The syntax that we follow here, the language that we write is TOML, Tom's obvious minimal language. Someone has invented it, but just don't get into the details of it. So it's a Tom's obvious minimal language. You have a name of the project here, version, description of the project. You can add your description here. Maybe this is a demo project for understanding distributing project. Okay. Second one, you specify what is the readme file of your project. Then it says what Python versions does your project need. So I'm saying I need the greater than or equals to 3.13. Any version that is greater than 3.13, it's okay. My project supports that. You say the dependencies, matplotlib, numpy, pandas, and rich library are my dependencies. Then you can have author's information. I left it blank here. Then the build system. So what are the tools that you use to build the project? Yes, and this is see, I told you, right? We need not we do not want to expose the docs. We do not want to expose the test folder to the user. These are for development purposes. While distributing the packages, I only need to distribute the source folder. So that's why I'm saying, okay, it's your homework. Understand the difference between source distribution and wheel distribution. take this as a assignment, and I leave this to your curiosity completely. I do not want to go into this source distribution and wheel distribution because it completely deviates our point of discussion here. So I'm saying in the wheel one, include the source folder, everything inside the source folder. Okay, I told you, right? We want to only expose the source folder, not the test folder, docs folder. We only want to expose this. I'm saying in the source distribution, uh, include the source. Then in the last final wheel file that gets installed, we include only the source folder and strip away the source. That means only package 1, package 2, package 3, package 4 and init.py gets exported. Okay, let me delete this init.py, it's confusion. Okay, so this is a Pyproject.toml. We're not getting into the complete details of how to write this, all of that. Just a quick introduction to I gave a quick introduction to it. Go to ChatGPT and ask it, hey, you have 2 hours to teach me everything about the Pyproject.toml. Do not teach me anything antiquated stuff. Keep it everything relevant to the modern standards and teach me the things which I casually use in my daily life as a senior engineer. Give this prompt and learn everything about the Pyproject.toml and how to write it. So I gave only a quick introduction. Okay, this one. Okay, given this Pyproject.toml, so this is the syntax. It contains all the information about the project and the build information. Okay. Now they said, okay, you have to. Let's come back to this one. You have to write a Pyproject.toml that describes your project. Then you understand building. Then they said, okay, we'll give you, we'll invent a package manager, which will make it, which makes it easy to manage the dependencies and install the packages. 3, we'll give you some build tools. This is so they are saying we'll give you some build tools like build command, other one setup tools. The most modern ones are hatchling. So these kind of tools. With these tools, you can build your project. And they said, hey, now upload the build file to pypy. So Python package index. It's a cloud platform, not a cloud platform. It's like a platform that hosts all the software repos that you write. You can host there all the packages like pandas, numpy are hosted on pypy, and hence we are able to install them. Upload it to pypy, and the users can install it using pip. So using our package manager. So this package manager is pip, Python package installer, or anything. The full form of pip is quite ambiguous. Okay, users can install using pip install your package name. That's it. So what are you going to do? You have to you have to write a Pyproject.toml that explains all the project, your project information and the build information, how to build the project. Then we'll give you a package manager and some build tools, and we'll also give you the Python package index, that platform where you can post your repositories or the projects, so that others can install those packages of your project using our package manager. Then that's so this is how it goes. This is the solution for the problem we faced here. Now let's do this practically. Now we will upload our, so we'll build this project. We have written a Pyproject.toml for our project. Then using the package manager, the pip, we'll build it and upload it to Python package index. Then we'll see what actually happens when you write pip installs package. Okay. At this point, let me this one, not this one. Okay. Not supposed to. Okay. So we have completed the first 4, I guess. Yeah. We have completed the first 5 in this one. We have learned the differences between package, library, and distribution. We'll revisit this again in the next one. It becomes more clear. Why do we need a virtual environment? The problems with the sys.path extend method of importing a other package. Then what's the solution? Problems, we discussed all the problems here. These are the problems. And what's the solution for it? It's a package manager, Python package installer. Your Python package installer, this is the platform where you can post your projects. Then build tools which help you to build your project. And we have also seen the Pyproject.toml syntax. A quick introduction to the Pyproject.toml syntax. So before we move ahead, I'll stop the video here, and I request you to revise all of this, and by the next video, study the difference between a source distribution and a field distribution. It's very important. I leave that to your curiosity, and I believe you will be able to understand it. Go to ChatGPT online anywhere and get it figured out. Know the difference between source distribution and wheel distribution. That's it. We'll see how to distribute our project by actually building our project, then distributing. In the next one, we'll see how to create a virtual environment. We'll start with a virtual environment, then we'll see how to upload it. And yeah, next one we'll use UV as a package manager. That's it. And yeah, I'll see you in the next one. Bye bye.